Welcome everyone. In this video, we will be learning about coroutines in Kotlin. What are those, why we need them, and where it exactly fits our programming needs. So let's get started. So first of all, let us understand how things exactly work. So suppose you are creating a function. So it will run one by one. It will first execute this line, then this, then third, and then last, and then it will end execution. And suppose you have created a proper application that have the extension .apk or .exe file. So for example, that youtube.apk or .exe is a executable file, and that is called as a program that contains a set of instructions that are coded into it and is stored as a file on your disk memory. And suppose when you are running your application, when you are running your program, so that will be converted into a process, and that program is now loaded into your memory or RAM and executed by your processor or CPU. So that program is now converted into a process, and it contains all these things, this register, stack, heap memory, and other things. And how these instructions that you coded into your program is executing, they are executed with a thread. So a thread is the unit of execution within the process. As you can see here, there can be multiple threads inside of a process, and each thread has its own independent registers and stack pointers. So if there is only single thread, then we will be running these program one by one. First we will execute this line, then second line, then third line. But in our programming needs, we have to do multitasking in every application. So that is not sufficient to have only one thread in our program. We have to do multiple tasks, so we will need multiple threads. And then what our CPU will do, so it will execute first this thread, and then it will switch the context to another thread and do all the tasks that is available in this thread, and then same to the third. So CPU will be using context switching to switch between threads and perform the instruction. But if our CPU is continuously switching our context between multiple threads, then it will be a costly operation. Context switching is expensive because it involves saving and loading our registers, switching out memory pages, and updating various kernel level data structures. Context switching is a whole different topics that we will not learn today. But how should we overcome this context switching and this resource expensive operation? So coroutines are on the rescue. Instead of creating multiple threads and making our CPU switch context between these multiple threads, what we can do is we can perform any heavy operation, and we can do multitasking with the use of coroutines. So suppose you want to make a network call here, and you have to get some data from your API. Then you can directly make a network call here with creating a coroutine, and after getting the response, then you can update your UI. So it will be very easy for you. But while you are making this API call and you are waiting for your data, then your UI should also not be blocked. That means you should be showing something in your UI. So that can be also effectively handled with the use of coroutine. Coroutines are so lightweight that you can run hundreds of coroutine and perform any task parallelly in your app, and your application won't lag. But that was not with the case of thread. If you are running hundreds of threads, then it will be a problem for your app. So what actually is a coroutine? In simple terms, you can just say coroutine is an instance of suspendable computation. If you know the meaning of this suspendable, then you can easily understand this statement. But if not, let me explain. So coroutines, it consists of two words, co and routine. Co means cooperative and routine means functions or operations, or you can say computations. So coroutines means cooperative computations. So here is an example function that you can use for your coroutine, and if you observe, we are using here suspend keyword. First of all, this is not a coroutine, this is a suspendable function. That means a coroutine function that can be suspended, and it should be run inside of a coroutine. So suspending means pausing something in between, and suspendable means anything that can be paused and can be resumed in future. So this is a suspendable function. That means we can pause the execution at one line at any point, and then we can continue it later. So any function that is suspendable, that means which can be paused and which needs to be paused in between. So that should run inside of a coroutine. So first it will act like a normal function. It will execute this line, it will get the API URL, then it will update the loading state of your app, and then it will make the call to your API with this API URL. But this API call is a heavy operation and it takes some time. So we have to pause the execution of this function at this line. Pausing of execution is called as suspendable behavior, and this thing can be only possible inside of a coroutine. So we will wait for the response from our API, and once we get the response, only then we will continue the execution of this function, and then we'll update our UI. So this is a thread of execution, like I told you the definition of thread. So we will be running multiple instructions one by one inside of a thread. But suppose this is a suspendable instruction, that means it is a coroutine. So for example, we started execution of this function, we executed first two lines and we are at third line. So now we have to suspend. That means we have to wait for this API call to finish, and till then we can do any other operations. So here this is a coroutine, so it can suspend. That means it will wait for this whole instance to complete, and then we can continue our operation. So this coroutine is now suspended, and now our thread can do other operations like this and this. And once the API call is finished, then we can again continue the execution of our coroutine inside of this thread or any other thread. And that is the beauty of coroutine. We can continue this suspended block inside of other thread also. Suppose there was also a other thread inside of our app, so that coroutine can continue in other thread also. So I hope now you understood what are coroutines. You can consider them as instance of suspendable block of code. So you might have also heard of a term that coroutines are lightweight thread. It is, but in the sense that it takes a block of code and it runs it concurrently with other part of your code. Usually in our applications, we create another thread to perform any heavy operation that should not be present in our UI thread. And the same thing can be done with the help of, guess what, a coroutine. So this is a suspend function, and how we can run it, we have to create a coroutine. But how can we create a coroutine? How can we create a suspendable block of code? For that, we have coroutine builders. We have three builders: launch, async, and run blocking. So these are coroutines builders, that are functions that we can use to create a coroutine. So suppose I am using here global scope dot launch function. And here this lambda provides us a suspendable block of code in which we can write our code for coroutine. So I will be also explaining all these terms. What are these coroutine builders? What is the scope? What is the coroutine context? All these things in my upcoming video. So make sure to subscribe the channel. So in this block now we can write any code that is suspendable, like this get data function. And here we can pass our UID. So here this is not an issue. And here you can see this symbol here represents that it is a suspend function call. Let me show you a quick example. And inside it, first I am printing the name of my current thread for my coroutine. So this is my first instruction inside of my coroutine, and I am writing the thread name in which this coroutine is running, and then I am using this delay function. So this is a suspend function which will delay, which will make this coroutine suspended, or which will make this coroutine pause for a few seconds, and here in this case 100 millisecond, and after that our coroutine will continue, and again we are printing the name of this thread. And outside of this whole coroutine, we are again printing a thread from our main function. So let me get this in a main function. So here is our main function, and if I run this program, then I am only printing hello main and then main. So that means hello main, and the thread name is also main. But why I am not printing this thing? Because the execution of main function is already ended after it executed this line, and after it ended, it is not even waiting for our coroutine to be started and printing these two lines. So what we can do instead is, if you don't already know, we can write this suspend function. So this main function can be also considered as suspend, and instead of print, let me write here println. Here you can see thread main, and after that I am printing hello coroutine 1, and the name of my thread is default dispatcher worker 1. But this thing is still not executing, so let me write here run blocking. And let me put this whole thing inside of this. And now I can use this launch only. So this run blocking is another coroutine builder that will block the whole execution. So now you can see there is something different here. Hello main. That means first this line is printing main, and the thread name is main. And for my coroutines that are run with this launch function, we are using hello coroutine from 1, and the thread name is also main here and main here also, because we are creating this launch function inside of this run blocking, and this launch coroutine will have the same thread as our parent. So that's why we are having the same thread. If I am using here global scope dot launch, then it will have some different output. Here you can see. Now we have this first statement is from this thread, and suppose after this line I am waiting for 200 millisecond. So that means this line will be executed, and this line will also be executed. This is running in main thread, and these two are running in our default dispatcher 1 or 2. the result can differ for you. This was just an introductory video for our coroutines, and we will also learn what are these dispatcher, and I hope this video served the purpose and now you actually understood what is a coroutine. If yes, then make sure to like this video, subscribe to the channel and access the Android interview playlist from the description.